Welcome to the software journey with GKey. Data warehousing concepts with real-time interview questions and answers. Lesson number 16. What are different data warehouse storage models like normalized versus dimensional storage model, columnar storage model, MPP storage model.
In this part of training, we are going to discuss about what are different data warehouse storage models in data warehousing. Let us see one by one. First, we'll look at normalized, that is 3NF, versus dimensional, that is star or snowflake schemas. In that first point is normalized 3NF storage. We'll see normalized 3NF, that is third normal form storage thing. The idea behind this normalized 3NF storage is many related tables designed to remove redundancy. That means if there are any duplicates or unwanted data, based on many related tables, we are designing to remove the redundancy. It is good for OLTP, that is online transactional processing, and sometimes for EDW core or ODS. Not ideal for reporting. That means the third normal form storage is not ideal for reporting. It is only for OLTP systems. Sometimes EDW core and ODS, we are going to use this normalized 3NF storage. Uses primary foreign key relationships and 3NF rules. These 3NF rules that we have discussed in the previous class. If you want full clarity, you can get into that class and you can look for that. And coming to this sample scenario, if we are taking sales here, table in three normal forms are like customer, product, sales order header, sales order detail. Coming to the sample data for a customer ID, name and city, we can divide like this. For product ID, product name and list price, we can divide like this. Sales order header also we can divide like sales order ID, order date, customer ID, and the sales order detail table also we can divide like sales order ID, line number, product ID, quantity and unit price. Coming to the 3NF diagram, that is ER diagram, entity relationship style. Here city can be connected to customer and customer can be connected to sales order header, and from there to sales order details, from there to product. Here many tables involves joins go through header and detail structure. And in the same concept, we are having dimensional modeling. Apart from 3NF storage, we are having dimensional like star schema storage. The idea behind this star schema storage is it is optimized for analytics and BI. It is a central fact table surrounding dimension tables. Star schema that we have discussed in the previous classes. The fact table surrounds with different dimension tables. It is easier for users and faster for queries. Why? Because for any dimension table that can be directly connected to the fact table to get the data with a very less number of joins. Same scenario converted to star schema, that means dimensions and facts. Here in dimensional modeling, we'll be having dimensions and facts as tables. Dimension tables are like dim customer, dim product, dim date, and fact tables are like fact sales. In fact sales, we'll be having different keys and measures. These are foreign keys from these dimension tables and some of the measures that we can have. And coming to the sample data for dim customer, we can have customer key, customer ID, name and city. And coming to the dim product key, product ID, product name and list price, and dim date. These are the different dimension tables. And coming to the fact table used to have different keys and the measures. These keys are from different dimension tables. They are treated as foreign keys in the fact table, that is fact sales. And some of the measures like sales amount, these fact tables used to have. The traditional star schema is to look like this. This is the fact table, which is centralized one, and these are the different dimension tables surrounded and directly connected to the fact table. Coming to the key differences between 3NF or normalized or dimensional or star schema. That means 3NF and dimensional modeling, there are key differences. Coming to the 3NF, many small tables and complex joins. That means here you can see n number of tables, and if tables are large, like many number, there would be joins also increased. For example, the table is subdivided into different tables. If you want to get the data from 3 columns from 3 tables, you have to have 2 joins. In such a way, joins are going to be increased in normal forms, like 3 normalized tables. Coming to the dimensional modeling, few big tables, simple joins. Here this would be the like fact table, and these are the different dimension tables. Here involves less joins. And 3NF is designed for update performance, whereas dimensional is designed for query read performance. 3NF is good for OLTP, that is online transactional processing, or ODS systems, and dimensional modeling is good for data warehouse and data marts. And now we have come to the second storage model, that is columnar storage. Here the first point is like row versus column storage. Take this simple table, sales fact row storage. Here this is a row ID, date column, product, customer, quantity and amount. These are the different metrics available here. Row store layout, it is traditionally like row 1, row 2 or row 3. In this way the data is going to be stored like this: row 1, row 2, row 3, and it is good for inserts, updates, not great for aggregations. Columnar store layout, stored column wise. That means date column, these are the different date values available. Product column, these are the different products, and the customer column, this is the different customer data, quantity and amount column. In this way the data is going to be stored. When you run select the sum of amount from select fact, that means a table where date is between this date, the engine reads only the amount and date columns. That means the date which is in where condition and the amount which is in select. Only the amount and date column selected here, not product, customer or quantity. For example, if you fire this type of a query on database, here it will select only amount and date columns. It will not go for row, product and customer. Like that, the columnar storage is too helpful here. The columnar storage diagram, logical tables as user access like date, product, customer, quantity and amount. Physical column storage representation is like date would be different dates available here, product, customer, quantity and amount, something like that. Benefits of this columnar storage design is it is excellent for data warehouse fact tables, mainly fact tables instead of dimension tables. We can go for this columnar storage. High compression, similar values compressed together, faster aggregations and scans available here, and it is used for SQL Server columnar indexes, Synapse, Redshift, BigQuery, Snowflake, etc. It is used by these many databases. And third storage model is MPP, that is massively parallel processing. Let us see the concept first. MPP is equal to many separate compute servers that are nodes working in parallel on parts of data. That means if you have millions of data, the data is going to be divided into different segments, and each segment is going to give into a particular node, and parallelly the data is going to be processed. In these kind of situations, we can go for massively parallel processing. Here, data is distributed across different nodes. Query is split into smaller pieces, executed on each node, then combined. Coming to the simple example, assume we have 9 million sales rows distributed across 3 rows. First node will maintain 3 million rows, that is for territory India. Second node 3 million for territory US. Third node 3 million rows for territory Europe. Query is like select territory, sum of amount from fact sales group by territory. The execution in MPP is control or head node parses the query, sends subquery to every compute node. Each node scans only its local partition and computes partial sums. Head node meets the partial results and returns the final answer. Let us see these things with the diagram, then you can understand. much better. These are the three different nodes, which is for India, US and Europe. Here the data is processed parallelly. Finally it will get into the head node and it will get into the reporting board, and the report is going to be displayed. Instead of like querying all the data one by one, here the data is divided among different nodes, and parallelly the data is processed, and finally it has given the results to the head node, and from head node the report is going to be displayed for the users or business people. This is about MPP cluster diagram. I think you got some idea about massively parallel processing storage model. And each compute node has local part of packed cells. For example, a set of distributed keys and hash partitions, CPU plus memory plus local disk are assigned storages are going to be used here. Examples of MPP systems are Azure Synapse dedicated SQL full, and Amazon Redshift, also an example for MPP, Google BigQuery, Snowflake database, Teradata, Netezza and Greenplum. These are the different databases available with the concept of MPP storage systems. And why MPP for data warehouse? It handles very large volumes of data, TB or PB, scales by adding more nodes, parallelizes, that means scans, joins, aggregations takes place parallelly by using MPP kind of storage mode. MPP is like massively parallel processing. That means if any business having the millions and trillions of the records, when you get into the reporting side, the processing will get or performance will affected. In such kind of scenarios, they'll choose this kind of databases, and these databases used to have MPP kind of a storage model in that, and they'll get the performance by using this kind of parallel processing. Coming to the quick comparison here, these are the three topics and the storage modes that we have discussed. First one is normalized versus dimensional. Second one is columnar storage. Third one is MPP, massively parallel processing. Key idea behind the first one, it is designed model of tables. It is a design model of tables, and a benefit for 3NF, OLTP or ODS. Star schemas are for data warehouse and data marts. That means 3NF systems are for OLTP and ODS systems, and star schemas are for, that means dimensional modeling is for data warehousing and data marts. Columnar storage, key idea behind that is how data is physically stored by column, and it is best for fast analytical queries on fact tables especially. And MPP, how queries runs across many servers in parallel, that is massively parallel processing, and it is best for very large data warehousing systems. In real time, some of the banking systems, insurance systems, they used to go for MPP kind of storage modes and the databases they require. I think you got some idea about different storage modes like normalized versus dimensional, columnar storage and MPP storage. Thank you.
Follow us on YouTube, LinkedIn, Instagram and Facebook. Don't forget to like, share, subscribe and press the bell icon to stay updated with our latest content. Join the GKey community and grow your IT profession with us.